Hi, this is Mrs. Wiederholt, and welcome to my lesson video on exponential equations. Now let's get started. First, let's review our laws of exponents. That will help us when we are trying to solve exponential equations. Since x to the first power equals x, then 7 to the first power equals 7. Since x to the 0 power equals 1, then 3 to the 0 power equals 1. So remember, anything raised to the 0 power will be 1. Now what do we do when we multiply like variables that have exponents? Well, we add those exponents. So x squared times x to the third would be x to the fifth power. And then look below that, what do we do when we divide like variables that have exponents? Well, remember, we subtract the exponents. Therefore, x to the sixth power divided by x squared would be x to the fourth power. Now let's look at the next row. If we have a variable raised to a power that's raised to another power, what do we do with those two powers? Well, we multiply them. So x to the m power raised to the n power is x to the m times n power. So therefore, if we look at our example, x to the third power raised to the second power is x to the 3 times 2 power, which would be x to the sixth power. Now, what happens when you have xy raised to a power? Meaning the two different numbers or two different variables are in the parentheses together and they are raised to a single power. What do you do then? Well, you raise each of them to that power. So in our example, x times y to the third power would be x to the third power times y to the third power. So remember, anything that's in the parentheses, each one of those terms would be raised to whatever power is on the outside of the parentheses. Now let's look at the law for raising a fraction to a power. Now if you notice, we have x divided by y, and there's parentheses around the whole fraction. So that means that whole fraction is being raised to the m power, which means the numerator, x, is raised to the m power, and the denominator, y, is raised to the m power. So now let's look at our example. We have x divided by y raised to the second power. So that would be x to the second power, and that would be over divided by y to the second power. Now let's look at our last law. What happens when we have x raised to the negative n power? Well, you simply move the variable and the exponent to the other side of the fraction bar. And you might say, wait a minute, x to the negative n power doesn't even have a fraction bar. Well, remember, it does. Invisible 1 is the denominator. So you take x to the negative n power and you move it to the other side of the fraction bar. And when you do, the exponent becomes positive. So let's look at the example, x to the negative 5 power. Well, remember, there is an invisible denominator, so we're just going to move x to the fifth power to below the fraction bar. And what happens? Well, if you move everything out of the numerator, there still is an invisible numerator of 1. Now that we have reviewed these exponent laws, let's learn some new ones to help us solve exponential equations. If both sides of an exponential equation have bases that are equal, then their exponents must also be equal. So here's the rule. If x to the a power equals x to the b power, then a equals b. What this means is if the two bases in the equation are the same, then their exponents have to be equal to each other. So let's look at the example. If 3 to the fifth power equals 3 to the x power, then x would equal what? Well, it would equal 5. Because 3 to the 5th power equals 3 to the 5th power. Now let's look at another rule. If both sides of an exponential equation have equal exponents, then their bases must be equal. So then the rule looks like this. If a to the x power is equal to b to the x power, then a equals b. Meaning, if you have an equation where both of your exponents are the same, then the two bases must be equal each other. So let's look at the example. If x to the 4th power is equal to 3 to the 4th power, then x must be 3, because 3 to the 4th power is equal to 3 to the 4th power. In just a few minutes, I will show you the importance of these two rules when it comes to solving exponential equations. Now let's look at a couple of examples. So let's look at our first example. 2 to the x power equals 8. Now we just learned on the previous page that if we had two bases that were alike, then our exponents would equal each other. But in this example, our bases are not the same. One base is 2 and one base is 8. So let's look right up here and let's read this. If both sides of an exponential equation do not have equal bases, they don't have equal bases, then try to rewrite one or both of them so that the bases are equal. So if I look at 8, well, I know that 8 can be rewritten as 2 to the 3rd power. So I now have 2 to the x power equals 2 to the 3rd power. And because my bases are the same, that means my exponents are equal. Therefore, x equals 3. Now let's try the second example. 9 to the x power equals 81. Well, 9 and 81, those are two bases that aren't the same. So is it possible to rewrite 81 using the base of 9? Well, 9 squared is 81. So I could rewrite this as 9 to the x power equals 9 to the 2nd power. And since now my bases are the same, that means my exponents can be set equal to each other. So x equals 2. Now, what are the two ways that you could check your answer? Well, the first one is pretty obvious. You could take what you got for x, like let's look at the first example here. We said that x equals 3, so you just plug the 3 in for the x and see if it's true. 2 to the 3rd power equals 2 to the 3rd power. So there you go. The second way you could check your answer is to use your TI graphing calculator. You could enter the left side of the equation into y1 of your y equals part of your calculator, and you could enter the right half or the right side of the equation into y2, and then you could look at the table. Now let's do some more examples. Number 1, 2 to the x power equals 32. Well, since my bases are not the same, I need to see if 32 can be written with a base of 2, and it can. 32 is equal to 2 to the 5th power. So we will rewrite this equation as 2 to the x power equals 2 to the 5th power. And because my bases are alike now, I can set my exponents equal to each other. And x equals 5. Now let's look at example 2. We're going to apply the same rules. It's just that this exponent now is a binomial, but you'll see the same rules apply and it'll work. Again, 32 can be written as 2 to the 5th power, so I'm going to rewrite this as 2 to the x plus 3 power is equal to 2 to the 5th power. And because my bases are equal, I can now set my exponents equal to each other and solve for x. So I have x plus 3 equals 5, and if I subtract 3 from both sides, I get x equals 2. So now let's check this one. I'm going to take my answer 2 and plug it back into the original equation for the x. So if I look at, I would have 2 plus 3, which is 5. And so 2 to the 5th power equals 2 to the 5th power. Now let's look at example number 3. We have 3 to the 2x minus 3 power equals 27. Again, our bases are not the same, but can we write 27 using the base of 3? Well, we know that 3 to the 2nd power is 9 and 3 to the 3rd power is 27. So here we go. Let's rewrite this one. 3 to the 2x minus 3 power is equal to 3 to the 3rd power. Now that my bases are the same, I can set my exponents equal to each other. So I have 2x minus 3 equals 3. Now if I add 3 to both sides, I have 2x equals 6. And now I can divide 2 from each side, so x equals 3. Well, let's check that one real quick. I'm going to plug 3 in to this x for that x, and 2 times 3 is 6. 6 minus 3 is 3. So I have 3 to the 3rd power equals 27, and that's true. Now let's do the 4th example. And they've made this one easy on us. The bases are the same, so I don't have to worry about that. I can simply set my exponents equal to each other. So I'm going to say 2x minus 1 equals x plus 4. And we're simply going to solve for x. I'm going to subtract this x from both sides, and I'm going to go ahead and add 1 to both sides. So that cancels out, and this cancels out. So I have 2x minus x is x equals, and 4 plus 1 is 5. So there we go, x equals 5. So let's check that one out too. I'm going to substitute the 5 for this x and for this one. First, let's look at this one. 2 times 5 would be 10, and 10 minus 1 is 9. So this is 7 to the 9th power. Well, if I plug 5 in here, 5 plus 4 is 9. So I have 7 to the 9th power equals 7 to the 9th power, and that's true. And so there you have it. You have learned how to solve exponential equations. So I hope this video has truly helped you, and I look forward to working with you again. Bye-bye.